So, what if I told you there is a way to monitor different Windows, Linux, and OS X flavors which are scattered through the premises or in the cloud? You'd probably be going like, what's this guy selling here? Well, the answer is nothing, because it's free. Hi, my name is Bogdan, and today I'm gonna talk a bit about Hubble, but before that, as Christina already mentioned, I've been working with the SOC. Now I'm working as a host intrusion engineer for the past 2.5 years in Adobe. So this will be a story in 3 parts. First, we're going to talk about what is Hubble and how to get it up and running, and then how to use it. So what is Hubble? Hubble is a modular open source security and compliance framework. It's designed for building robust host monitoring capabilities, and it leverages the OS queries capability. It's built on top of SaltStack, therefore at its core it's written in Python. It was open sourced by Adobe in early 2016 at SaltConf. It's publicly available in Git at github.com/HubbleStack. It's a high performance and low footprint tool, which is, you can run it out of the box, but it's also highly customizable to fully fit your environment and your needs. And as mentioned before, there are multiple components to Hubble, and these are Nova, Nebula, Pulsar, and Quasar. So let's go a bit through each and every one of them. So the first one is Nova. It's Hubble's auditing engine. It's designed to assess the security and compliance of a system. Basically, you're gonna define a baseline and then run a series of checks against that baseline to see where your hosts stand. It can be used for CIS compliance as well as for CVE scanning, and it integrates with owners.com for CVEs. And you can run it as a one-off, or you can schedule it to run whenever you want, daily, weekly, whatever. It will tell you basically the name of the check, the name of the number of the CIS, a short description of it, whether it passed or failed that check. And at the end, you're going to get a compliance report against the series of checks you ran. So yeah, basically with this, you can ensure that all your hosts are hardened, or the configurations are the way you want them to be. The packages installed on the system are the ones you want to be. So let's move into the next module, which is Pulsar. It's Hubble's real-time file integrity and security events system. It's designed to be lightweight and can notify you of file changes in real time. And a lot of people will say to this, oh, my infrastructure is immutable, no one changes it, we only do it through the config management process. I wouldn't be so sure about that, and to this I'm not referring only to the malicious actors, as an admin who doesn't follow procedures and make changes on his own can basically induce a lot of operational issues and no one would know about them. This module is also customizable. You can you can point at different directories and exclude the directories you do not want it to look at, as in look at var log at var, but not at var log, as that will change constantly with Linux logging stuff. Also, you can change the type of attributes, the file attributes you want it to grab, checksums, hashes, whatever. So next on the list, it's Nebula. It's Hubble's inside module, and it's designed to query the system. It's heavily ties into OS Query, and for those of you unfamiliar with OS Query, it's a tool which was open sourced by Facebook in 2014, which took a very different approach to host-based monitoring. Basically, it reviews your system as if it were a database, and you can query that database with SQLite and gather a lot of cool info out of there, as in processes, configurations, memory, all that type of info which is really useful to an analyst when he is looking for malicious activity. This OS query has a lot of tables which grab the information, which are written to hold the information grabbed from the system. But you can even write your own through the existing API query. It can be done in C or in Python. It comes with OS Query I, which is an interactive shell where you will run your queries for a sweep or a one-time or tests, and then you can schedule those queries through OS Query D, which is the host monitoring daemon. And with that daemon, you schedule them to run on different intervals. It grabs the info, it logs it, and then you can use it further. The tool is really cool and all, and the info it provides is really nice. However, it's a bit of a pain to get everything going in the beginning. But we thought that the cool info is worth it, as Nebula basically does all that work for you. It comes with a high variety of already existing queries, already scheduled to run on different cadences. And also it ties in nicely with the reporting system, Quasar, about which we'll talk about next. So this is basically designed to collect and deliver data for processing. It's the glue that ties everything together. It gathers the data from all the previous modules and it delivers it to your existing logging infrastructure. From there you can build alerts, dashboards, correlate stuff, everything you want to do with it. Also, these notifications can be forwarded also to your email or Slack or other team collaboration tools, not just to your CM infrastructure. So now let's get to Hubble up and running. We have all these cool features. How do we get them to work? Usually this is the dreaded part when we're talking about open source tools. Most of them need a lot of tinkering before you get everything run the way you wanted to. But with Hubble, it's pretty easy. And before I get into this more, I want to share a short story of how I got to work on this project. Midway through the summer, when this project of building an environment and create content for analysts to use was in its infancy, my awesome colleague from India, which heard that process in the beginning, decided to move into a different role. And after a very elaborate decision process, as in eeny, meeny, miny, Bogdan, I was chosen to help this process. And at first I was afraid. I was petrified. I'm gonna stop. But my colleague from India had more than 2 years of sysadmin experience. She was awesome at this. She was really good. She was a cloud instructor, really knew what she was doing. I could barely string CLI commands together. Just so you know where I was before I started with this. So it's not hard. So yeah, with this out of the way, let's go into installing Hubble. So basically on Linux, all you need to do is install Git and Python iNotify. Then you need to download the latest release from the GitHub page, install it, and then you need to modify the config file, which is located in bin etc hubble. There you'll have instructions in the config file, you will see later. But basically you need to uncomment the scheduler stuff and the returner and give it where you want it to return. Index, token, how you want the data to be split. Just make sure you restart the agent whenever you make changes. I told you I wasn't very good at this. This kept me busy today. So now let's move on to Windows. And on Windows, you double click. You download the latest release and install it. You get a prompt. It asks again for your returner for your CM info, tokens, index server. You prompt them in, and you're gonna see data in your CM. There is a third version of Hubble, which runs on top of an existing full stack infrastructure. It leverages the master and minion agents, and basically that one can be used to have only one agent and not multiple agents. You kind of only should use it if you have full stack as your existing orchestrator and you want to maximize performance. I'm not going to go deeper into this, but it's a niche scenario, so I thought I'd mention it. So yeah, that's it. Now you have Hubble up and running. So from here, you can go out and customize things. Clone the Git repo into your own. Add existing queries. Modify the schedule. I don't know, modify the Nova profiles. Those are in YAML. Just write the checks in there and you're gonna get what you want. Modify the file paths on which you wanna be looking at and Pulsar. So yeah, that's basically it. So now that I've given you a short overview of Hubble, let's go a bit through what it is and what it isn't. It is a great addition to every security infrastructure for all the information it provides, and not all the tools provide all this info. It can also help with operational issues, troubleshooting those with the process info it provides. And it provides backup from OSs that don't get much love from the security industry, as in Linux and OS X. That's why it was built in the beginning by Facebook. And it can also help with hardening suggestions and CVE detection. But what it isn't, as you've all seen, it doesn't cover any of the capabilities of an AV or an IPS system, so you should use it in conjunction with those. And you should also scan with a vulnerability scanner, as that thing does a more active search and that just matches the packages to vulners.com. So, with all that being said, let's move on to the demo. I want to show you some cool stuff. This is me demoing. Let's look at the Nova data in the terminal. This is basically how you call it, Hubble, and then the module that you're calling, Hubble audit. And it runs a one-off scan. You're going to see at the top the percentage, the failed checks, the CIS numbers, and the description, and also the successful ones. Basically, this is Nova in the terminal. For Nebula, you can work it the same as in Hubble, the module which you're calling, Nebula queries, and then you have another argument for how you schedule it. We've called the hourly queries now, and I have events for the cron tab, which is always there. You're going to see the commands, which are cron, and the cron schedule here. You're going to see the cron files, all that stuff. And login history, the process ID, the username which logged in, and it's a user process, so it's still active. You're going to see that process from view 10 if it's not. And you can schedule it with the other arguments which I already have, day or 15 minutes. This is the way it's by default scheduled. So let's look a bit at OS query. I'm just going to show a couple of simple queries. Call the shell, and then please give me everything from the user's table. If you don't know the tables which are available, you can just call schema in this shell and get everything, or just go to OS Query's website and have all the tables listed with all the info. So now it shows all the info it gets for the users, and then you can apply simple logic to it. Like, show me those which have the UID under 100, so those are the more privileged users, the roots and the whatnot. And yeah, this is going to show a basic config file for Hubble, just with the uncommented stuff. And as you see, you have instructions on what you need to do. So it points to the GitFS remote, the Git from where it's getting its data. This is the public one. And then how it's scheduled. So we have it scheduled, audit daily, run it every 24 hours, and then Nebula 15 minutes, hour, and again day. Also, the returner to use, And here is the returner configuration, bubble stack, return, Splunk, token, index, indexer. And then how the data is split into source type, so we don't pay through that much info. And at the end, this is the Slack for notifications to be sent on Slack for file changes. So now let's look at the data in Splunk. Because here you can process it properly. So we're going to see the compliance percentage. This is how it shows in Splunk. And then you're going to get a different line for each of those checks. So I have successful checks. I have permissions enabled on Etsy password. Don't judge. This is the default Azure image, so it's not me. And the name of the check and what it is. So now let's go into the failed ones. And yeah, basically people can execute from that, and that's the big no-no. That should be fixed. And also SSH is not configured the best way, if I remember correctly. Yep. So these things should be assessed and acted upon in a normal environment. And let's look a bit at the Pulsar data, and we're not looking at it only in Splunk. I just wanted to show how fast the data goes through. So it's created a bin file. Hello guys. Don't judge, I'm a slow typer. And then we're going to switch to Splunk and see the changes there. So now this is running in real time, and the file should pop in any minute now. So the first batch, it comes with the swap files created by Vim. Those are where it caches the files before you save it, if Vim crashes or a PC crashes or a computer crashes, to have the info. So here you have all the info you want on who changed the file, the user, the object path, the file hash, the create time and the modify time, the file name. So yeah. Now, we're going to look a bit at Nebula data. We're not going to look at all of it. These are some of the queries, and I'm going to show some of the ones which I found interesting. This is the kernel info query. It gets you the boot device, boot arguments, the file path of your kernel, your hash, whatever. I mean, this is good for detecting stuff which tampers with your kernel in Linux. And then we're going to look a bit at the login history. So this is pulled from UTemp, if I remember correctly. Again, we're going to see the process ID and when it was queried and when the user logged in, and which user it was, and we see here user process. So that's still active. Below it was a dead process. So when the session stopped. So let's look at more fun stuff. Running processes. These are more dynamic. So as you see here, these are pulled more often, not just daily, because yeah. So again, we see the command line which was ran. We have a bunch of arguments in there. Again, users, hashes, start times, whatever. Process IDs, parent process IDs, which process it was. If you see like Python starting something without a command line argument, a connection, that's a bad thing. Your Python was hijacked. And speaking of that, we're going to also look at the query, the established outbound query. This is a nice one in my opinion. It looks at processes who establish a connection outbound to a different machine, not to the internet, but you can look for that with external IPs in there. This one actually connects outside of my environment. It's an Azure monitoring agent. And again, we're seeing hashes, parent processes, parent process IDs, and basically you can see how we can correlate alerts based off of this data. So what I did with this, I basically put all the info into one dashboard, as in, let's assess a system quickly. So we're going to have the compliance percentage, version, uptime, kernel, network interface, local user accounts, the ones which are already in place, the logged in user, cron jobs, running processes, processes with an established connection, and all the audit checks. So this would be a good starting point. Like if someone says, hey, this host was popped, just shove it in here, see all the info, and that's a bit of a spoiler alert for later in the demo in a few minutes. So I'm going to be upfront. The Windows part is not as developed because it was focused towards Linux and OS20. But this is what I did for my Windows host. Again, the normal stuff, the summary with network interfaces, but you still get the running processes and processes with an established outbound connection, ports, process IDs, whatever. You get the installed programs here with uninstall string and install string, also the audit checks and the file elements. So the next host, which I'm going to pop in, I actually tested host validation framework, open source. It's called Smoky Jab. It was open sourced by Kevin Lustig at SaintCon. And basically what it does, it mimics what an attacker might do once he jumps on the box. So when an attacker dropped the key, which this dashboard caught, he created some rogue suite files, and then created a user account, which the resolution is not the best, and he created a cron job for persistency. So basically, I just did this and then popped that framework. It caught like half of the checks, like with what was written in the beginning. So yeah, this was my demo on Hubble.